So the last concept we're going to do, and then I'm going to give you guys a worksheet to work on these ideas with the worksheet. So the last two ideas here is function form. What does function form mean? Well, look at the front page. Every one of those is in function form. So could you tell me what function form means? It is an input-output, but it's written in a very special way. It's got to look like a function. So what is a function supposed to look like?
An equation.
It's an equation. What more about it? What else? It is an equation. What's it going to equal?
Y.
Yeah, that's what it's supposed to do. Function form equals y. Why? Did you ask why? I guess you did. What does y represent? Is it domain or range?
Oh, that would be range.
It's the range. And the range is otherwise known as what?
The answer.
The answer. What's some of the vocabulary words?
Y variable.
It's a y variable.
Dependent variable.
Dependent,
Output.
and it's the output. So function form has the y equaling whatever else is, because we put in something for x, we do stuff, and it spits out our output. That's why it must be y equals. That's why it's function form. Does that idea make sense?
Yeah.
If it does, then as soon as I say function form, you're like, oh, I gotta get y by itself. Lovely?
Yep.
All right. What does function form mean?
Equals y.
That's kind of the idea. To get y isolated, y equals some stuff. That's what function form is. And we need function form so we can figure out our outputs. I put in something, I chug it, and it spits out the y. So function form gives us our y values when we put x values in it. Guess I'll write this down. Gives us outputs. That's really the reason why we want it. You all set?
Sure.
Can you write the first one in function form? I got one nod. It's not that hard, actually. Don't overthink it.
Yes.
Oh, wait.
Are we trying to get rid of that?
Well, you know what it's supposed to look like, right? Look in your front page again. Sit there right in front of you again.
Y.
Y equals something.
I think.
Hello? Yes, he did.
I don't know.
Yes, he did. Yep, thanks. Bye.
All right, I'm gonna spitball this one. Is this right?
All right, what'd you come up with?
Y equals 3 plus 2x.
Y equals 3 plus 2x.
Yeah,
Are you a term tosser?
Am I right?
I know. But you're on the right track. So Noah had said y equals 3 plus 2x?
Yep.
3 plus 2x. There is 2 right things and 1 wrong thing about what he said. 2 out of 3 ain't bad, but this is not right. Trevor?
The 3 has to be a negative.
Why?
Because if you want to move it to the other side of the equal sign, you have to minus them.
And that's why I say term tosser. All you did was chuck the 3 over on the other side of the wall, right? Can't do that. If you want to move something from one side of the equation to the other, you got to get rid of it. So this is how it should have been. You'd subtract 3 from both sides and now it's correct. Okay? So I'll use that term tosser idea to try to remind you guys, don't just toss them over, you gotta undo them. And as Trevor's saying, if you want to move it to the other side, it turns negative. It always does. It's always been that way. And if it's negative, it turns positive if you move it. Okay? So if you can latch onto that idea, that's a real quick way of doing these things as well. All right? In other words, we actually did the onion technique on this problem. Instead of getting x by itself, we got y by itself. And I like how Dylan's like, huh, really? Didn't I just get rid of the 3?
Mm-hmm.
Yeah, in this case, I'm trying to get y by itself, so I start circling the y, then whatever else is on that side. Get the idea? All right, same thing over here. I can do the onion technique on this one. And what would I do for this one?
Subtract 4.
It's
you're
more
gonna
like-
add, you're gonna add
yeah, you're
what's
gonna
negative.
add. And what else? What do you add? Just a 4?
4.
4x.
It's a 4x.
Oh, the 1.
Yeah, it's a 4x that you're adding because I want to get rid of the negative 4x. I want to make that 0, right? To make it 0, you add whatever it is on the opposite. Do that to both sides, and y equals what?
3.
Oh. Can't combine unlike terms. 4x plus a negative 1, that would work. 4x plus a negative 1, 4x minus 1, negative 1 plus 4x are all acceptable ways of writing this. Does that make sense? All right. Take a moment and try the other two. See if you got this down, and we'll go over the answers. All right, how do we do?
Just keep using the last one.
Okay. Justin, what did you do for the first one?
8 plus -2x equals -y.
I agree. And then are we done?
So you don't even negative?
Not quite. You do. So did you use the onion technique at all?
Yeah.
All right. So you subtracted 2x from both sides, right?
Yeah.
Lovely. And then this is what you said. You said 8 minus a 2x equals a negative y, right? Is y by itself?
Yes.
Not quite. I don't have y. What do I really have?
Negative.
I have a negative y. It's not really by itself. I have the opposite of y. I don't want to know what the opposite of y is. I want to know what y is. So what do I still have to do to truly just get a positive y there?
Move to the side of y.
I could move y to the other side, but then I got everything over here and I'm still trying to get y by itself. You could do it that way. What else could I try to do? Yep, that's what Trevor said. I could add y to both sides. If you do that, that's what you have. Is y by itself anymore? No. Then you'd have to keep going. So I wouldn't recommend that, but you could do it this way. Trevor, you have another idea? Or were you gonna keep going with that one?
I was just wondering, would it be right if you took the negative, or the 8 and the negative 2x, and then just moved it to the other side and have a positive one?
Yes, you can. So what Trevor's saying is he's just gonna rearrange them all. He's like, I'm gonna move y over here, I'm gonna move 8 over here, and then negative 2x over here, and as a result, all the signs change, right? You can do that. There's a quicker way. Does anyone know what this number is in front of y? It's a negative 1. And if negative 1 is being multiplied to y, what can we do to it?
It's like 14.
If negative 1 is being multiplied to y,
Make y negative. Make it positive.
how do I make it a positive?
Let's do a positive
Making y
equals
negative.
You can multiply by a negative 1, or you can divide by a negative 1. You can actually do this. You can divide, or you can multiply by a negative 1. And what happens? A positive divided by a negative
negative.
turns negative.
So y equals negative 8x.
And a negative divided by a negative.
Positive.
So what if I wrote that? Is that right?
Wrote this?
Yeah.
Yeah, that's right.
That's what I wrote the first time. Okay.
Yep. And there's two ways of doing it. Trevor said, hey, I can actually move things over and the signs change when I move them from one side to the other. It works perfectly. Lovely idea. You can do it that way. Or you can multiply or divide by a negative. Because that's all we're trying to do is get rid of that negative on the y. So far, so good? All right, anyone want to tell us how you started the second one? I mean, what'd you do? Did you do anything? Why not? Justin?
I didn't get y by itself, I got 4 plus 2, or 4 plus 2y equals x.
4 plus 2. All right, so this is what you did. You went ahead and you added 2y to the other side, right?
Yeah.
Let's go with that for a second. And Michaela, we'll come back to your idea now. Unless, did you do the same thing?
I was just gonna say, once you just get x by itself.
Okay, so you can do that. But I still don't have y by itself, right? So this is fine. Now what do we do?
Get rid of that.
Hold on, Trevor. I appreciate the participation, but we gotta get other people involved because they're just sitting there like bumps on a log.
That's-
So two, you thought of the same thing. And I'm not saying it's wrong, it's a fine way of doing it. Lovely, great. What do we do now? Because y is not by itself yet.
I mean, you can do that.
We can do the onion technique now. And what would that look like? Circle to y, then the 2, and then the 4. And this tells us to do what?
Subtract 2.
Subtract.
4.
Subtract the
Oh,
4. So if I subtract the 4, I'm going to get this.
Then minus 2 from both sides.
I can't subtract 2 because it's not being added to y.
Divide 2.
I'd have to divide by 2. Okay. So what's x divided by 2? How many x's do I have if I divide it by 2?
I know. 2.
And I divided it by 2.
0.
Half.
I have a half x. There's a half of x. I have half of it. I took x and I divided it into 2 pieces. I got half of it now. Does that make sense?
Kind of.
This is, we've done this kind of thing before. The pretzel technique. What's negative 4 divided by 2?
Negative 2.
Negative 2. Now y is by itself. Harder example at the end.
That'd be like a test question.
Definitely. This is where we're headed to. So in order to graph lines, we need to rewrite equations. This is just the beginning. So if they're already written nicely, we can graph lines right away. But there's going to be a time when they're all messed up and we've got to rewrite them so we can graph them. And this is exactly what we need to be able to do. So this is the start. And we've got to make sure we get this down. And the onion technique works perfectly with stuff. So the idea is, hey, in order to graph a line, I need to get y by itself. I apply the onion technique on y. So all these things are building on each other. Okay, and they're usually just 2-step equations. Make sense? All right, now, are there any questions on all these things? We went through every type of example, and you have stuff on your notes. Does anything confuse you or didn't make sense as you look over this? So we understand how to get into function form. If you gotta get y by itself, you can use the onion technique. Do you understand, determine whether an ordered pair is a solution? You plug and chug and verify. Do you understand how to come up with an equation? Mariah led us through that yesterday. That one's the hardest one. Do you understand that you need to write a table out and tell me what the domain and range are from the inputs and outputs? Those are really the ideas that we went through. You all good with that? Okay, so I'll give you guys the rest of the time to work on the worksheet. Due for tomorrow. No questions right